Welcome to homework.
In this problem, we are given w, which is a function of u and v, the function f. And we're told that it satisfies the Laplace equation in u and v. So this is the Laplace equation. And we're told that the variables are u equals x squared minus y squared over 2, and v, which is x times y. So this is the information that we're given. And then we're asked whether w satisfies the Laplace equation in terms of x and y. So does this equal 0? Well, so we need to work out wxx and wyy. Wxx is equal to d by dx of, then using the chain rule to get just wx, we have wu ux plus wv vx. But then this is equal to, if we then use the product rule on each of these terms, and then also the chain rule, we get that this is equal to w ux ux. I'm going to move to a different line. This is going to take a lot of room. So this is equal to w ux u sub x plus w u sub xx plus w vx vx plus w v vxx. But keep in mind that a term like this is really w u then u x by the chain rule. So that whole term becomes equal to w u x squared, because it's w u times u of x and then times this additional u of x, plus w u xx plus, then we're going to do the same thing with the v term. So w v vx squared plus w v vxx. And then the y looks exactly the same, except, meaning wyy will look exactly the same, except we just replace all of these with y's. Whoops. So if we want to make this into wxx plus wyy, well then, let me draw a line to distinguish between what we were doing. So this is the new thing that we're working on. So we need to incorporate the terms for y now. So this is uy squared plus wu uyy plus wv vy squared plus wv vyy. Well, as you can see, if we take the second derivative of v with respect to x or y, it just goes to 0. So these terms go to 0. And then we can start plugging some things in. So let's work out some derivatives. Ux will just be equal to x which means that uxx will be equal to 1, and then uy is equal to minus y, and uyy equals minus 1. And then vx is equal to y, vxx, as we said, is 0, vy is equal to x, vyy is equal to 0. So if we start plugging in these numbers, and then let's also use the fact that because we have that this is true, it tells us that since f is just writing w in another way, this tells us that fuu equals minus fvv, which tells us that wuu is equal to minus wvv. So we're going to use this fact right here quite a bit. Okay, so now if we resume our calculation of wxx plus wyy, this is equal to wuu, and then u of x squared, which is x squared, plus wu times uxx, which is times 1, plus, well, remember, for wvv, we can just write that as w minus wuu, and then vx squared is equal to y squared, and then once again, the last term on each row is just a 0, plus wuu, and uy squared is equal to minus y squared, which is just y squared, plus wuu times uyy, which is minus 1. So we can just bring this out as a minus. And then minus wuu times v sub y squared, which is x squared. So you can see that this will cancel with this cancels with this, and this cancels with this, so forth, which gives us 0. So we have found that w satisfies the Laplace equation in x and y when f satisfies the Laplace equation in u and v, and we also have these specific variables here. But that completes the problem.